Good morning. We got a couple people gone. Allie's gone. Who else is gone? Who sits here? Tyler. Oh yeah, Tyler's gone. So hopefully you guys are like watching. If not, watch it later. All right. So Anita, what's the first thing we do here?
Find delta x.
Okay. And what is delta x here?
It would be 2 over n.
How did we get 2 over n? It's exactly correct, but how did we get it?
3 minus 1 over n.
And this is, I can call that A and I can call that B, correct?
Correct.
All right. 2. Aaron, what's the next thing I do?
Find c sub I.
Find c sub I. And c sub I is what here?
1 plus 2 over n.
2i over n, right? Or you're going to say 2 over n times I, right? All right. Number 3, Ellie, you have no idea because were you on vacation? Was it somewhere warm? You went to Alaska.
No, we went to
Chattahoochee State Park, which is like up by Duluth, isn't it?
Yeah, it's about an hour north of Duluth.
Okay. Good. Nice. And you camped in a tent? No.
We went to the little cabin.
Okay. All right. Megan, what do I do? All right, oops, squared. All right, 2 over n summation. This is the width, correct, Megan? That's the width of every rectangle is 2 over n. And the height of every rectangle is 1 plus 2i over n squared, correct? And I is just moving right down the x-axis, hitting all those different heights. Would you agree? Okay. So, Hannah, can you multiply that out? It should be a trinomial. Can you see it okay?
Yeah.
You want to make it a little bigger?
Can you?
You can, or you can look at your own paper. Okay? I'll make it bigger.
1 plus 4i over n.
Excellent.
Plus 4i over n squared.
I squared also, right?
Yeah.
Okay, super. All right. I'm going to make this into how many summations, Cullen? 3. This one's going to be like this, correct? Of 1 plus, right? Would you agree? And then I'm going to have the summation of I equals 1 to n. And there's going to be an I in here because there's an I. But out front will be what? 8, because 2 times 4 is 8 over what? N squared? Because I got n times n. Are you okay with that? Yeah. Okay, plus Brady. I got another one, right? I got I squared in here, correct? What will I have out here? 8 over n cubed. Perfect. All right, I'm going to take the limit right away so I don't forget because I don't want to take the limit of nothing. So, Hillary, I'm adding 1 n number of times, and then I'm going to multiply that by 2 over n. What will that give me? 2. Plus 8 over n squared times what?
N times the quantity n plus 1.
Oops. N times n plus 1 over 2. Okay? Plus 8 over n cubed times
N times the quantity n plus 1 times the quantity 2n plus 1 all over 6.
over 6. Abby, can you take the limit as it is, or you want me to simplify? Okay. This n will simplify with that n down there. This can be there's a 3, and that'll be a 4. And this n, and that becomes an n squared. Did that help? Okay. So what's the limit as n goes to infinity of 2?
2.
So this will be 8 times the quantity n plus 1 over 2n, right? So what's the limit of that?
4.
Plus, don't forget I got a 2 here, correct?
Yep.
8 thirds. Do you get 26 thirds when you do that? 26 thirds, people are saying yes. All right, super. Alrighty, indefinite integral. So I've defined a definite integral. F is defined on a closed interval, and the limit below exists. So this is called a definite integral because it's got an a and a b. It's got limits or bounds, or what I call a hat and boots, and it's equal to the limit. These represent all the heights, and this represents all the widths of the rectangles, correct? And then all I did was bring it out front, kind of like what Megan had us do, right? So this is what a definite, oops, you can't see anything at all because I don't know how to, there, is that better? It'd be nice to see. Here are my heights, here are my widths. This is a definite integral from, can you tell me, Maureen, what an indefinite integral looks like? It looks a lot of the same like this, except it's a little different. No, we don't do summation. Kyle, do you know what a indefinite integral looks like?
Just like that, but without the B and
Just like that, without the B and
the A.
the A. So, Kyle, what's the purpose of the definite integral? Find the area under what? F of x, right? From A to B. Okay. We in BC we do it from negative infinity to infinity. What's the purpose of this, Holland? To find the antiderivative. And what's the antiderivative in this case? What would it look like? Plus C. Only 10 people forgot the plus C. 10 out of 38. Probably said that too many times. Can I flip the page over? All right, now, unlike me, Emma, who can be rather sometimes too intense for his own good, okay, on the AP exam, they're going to give you a problem like this, and they don't care how you solve it. Right now, we have two ways we could solve it. Which way would you choose? Okay, what would be the easier way for you? Well, you have to Reimann gives you the approximate area. We have to have the exact area. Okay, let's do that. So what's delta x in this case? 2 over n. Okay, what's c sub I? Perfect. And so then I'm going to have 2 over n summation I equals 1 to n of 2 times 1 plus 2I over n plus 1. Would you agree? And then I can say I got 2n over summation I equals 1 to n. 2 times 1 is 2, plus 1 is 3. Are you okay with that? Plus 4I over n. Would you agree with that? And then would you say I could break this up into 2 summations? Plus, and then this one would be I equals 1 to n, and there's I by itself. But what would be in front of here? 8 over n squared. So now I'm going to take the limit. I'm going to bring it up here. So I'm going to take the limit as n goes to infinity. Ooh, what does this become? 6. Plus, this is going to be 8 over n squared times what?
N times n plus 1 over 2.
Are you able to take the limit of that in that form, or you want me to simplify it? To be 10. Right? Now, here's the second way. An AP would be okay with this too. So here is 1. And if I plug 1 into there, I get to 3. And then I get 2, and then I get 3. And if I plug 3 into there, I get up to here, which is 7. And then they'd be okay with you doing this. This area is 6. You see how I get 6? And this is 2 this way and 4 this way. And 2 times 4 divided by 2 is 4. And 4 plus 6 is 10. They'll let you get by with that. In fact, there are going to be some problems with that's the best way to do it. Okay? Especially if they give you a picture. Okay, we're shifting gears slightly. Aaron, what kind of integral is this? Indefinite integral? So do you know how to figure out the particular solution? Find the particular solution for this indefinite integral that passes through 1, 5? Not sure? Okay. What if I asked you to find the general solution to this? Would you be able to do that? Yeah, what is the antiderivative? Perfect. That's the general solution, right? It's a general solution because C can be any arbitrary number we want it to be. Because we have this point, we can figure out C. Do you know how we can figure that out? This 1 is the what coordinate? So I'm going to put 1 into here. 1 squared plus 1 plus C. Guess what it has to equal? The y coordinate, which is 5. So, because f of 1 equals 5. You see that? So, what would I get here? 3 would be equal to c. So, what's f of x equal to? There's my particular solution. That would pass through that point. Okay? So, how would I, Josh, figure out capital F of 3? Put 3 into here? Okay. So F of 3 would be 3 squared plus 3 plus 3. Notice the 3 threes. What is that answer? 15. So, F of 3 equals 15. Would you agree? So, right here it says, what is F of 3 minus F of 1? Kurt, 10. You see that? Huh. I'm going to ask you a few questions. What's capital F? The blank of blank. Capital F. Why do we write it capital F? Because it represents the what? The antiderivative of F, which is here and here. What's 3? What is it here? What's 3 here? What letter? B. What's 1? A. Huh. The antiderivative with 3 put in it minus the antiderivative with 1 put it gave us the exact area underneath that curve. And who figured out the antiderivative? You did, didn't you? It was a relatively easy job. A lot easier than that. Wouldn't you say? So, what does it represent? The distance between the y values generated by A and B into F. Right? Aren't these the y values? 5 and 15? Isn't the distance between those two y values 10? Isn't that the area underneath that curve is 10? Let's look at example 2. What kind of function is v? Oh, by the way, there's a typo here. This should be 3t squared. What kind of function is this? It's a function that generates what? Velocity. Would you agree? It's a velocity function. So if I put 1 in there, I'm getting 3 feet per second. If I put 2 in there, I'm getting 12 feet per second. If I put 5 in there, I'm getting 75 feet per second. Correct? It generates velocity. Okay? Cameron, this is not a straight line. So we got to do it the old-fashioned way. We got to figure out what delta x is. 2 over n. We got to figure out what c sub I is. So 2i over n. Okay. So we're going to have a summation symbol. I equals 1 to n. In front will be 2 over n. Would you agree? And then I got 3 times, what goes in here? 2i over n squared. Would you agree with that? Okay, so that gives me, well, 2 times 3 is what? And then this is going to become a what when I square it? It's going to become a 4, right? Yeah, so what's 6 times 4? 24. Inside here, I equals 1 to n. I'll have I squared. Here's n. This will also be an n squared, right? So what's n times n squared? N cubed. Beautiful. So I'm going to take the limit as n goes to infinity of 24 over n cubed times. Do you know the summation of I squared? You said over something, I didn't hear it.
Over 6.
6. Okay, are you able to do that in your head, or do you want me to do some simplification? Okay, what are you going to get? Eight. Awesome. Okay. Gabby. 8 what? Okay. This curve looks like this. When I put 0 in here, it's at 0. When I put, what do we go to, 2? We're up here at 12. What are my units over here on the y-axis, Gabby? What are my units? It's 12 what? You know, when I put 2 into here, 12 what? feet per second. Right? Would everybody agree? And this is 0. This is 0 to 2 what? Seconds. So infinite number of rectangles, right, Gabby? I'm going to blow one up 40,000 times its real size. There it is right here. It's seconds across. Would you agree? And it's feet per second up. So this is 8 what? 8 what? 8 feet traveled from 0 to 2 seconds. So in this case, the area underneath that curve is a distance traveled in that interval. Does that make sense? Are we okay with that? Next page. I give you a beautiful graph. This part right here does not exist. This part does not exist. It is a closed interval from 0 to 7. So right here, this is 7. That's a 4. This is a 2. This is a 0. And this 13 is the area underneath the curve. This 8 is the area underneath the curve. This 43 is the area underneath the curve. This right here is f prime. So back to you, Nikita. What can you tell me about f from 0 to 2?
F is increasing.
Why?
Because the derivative of f is positive.
Perfect. What can you tell me about from 2 to 4, Aaron?
F is decreasing because the derivative of f is negative.
Perfect. Ellie, and I know you've been up north. Were you freezing ever? Were you ever cold?
A little bit, but it was an enjoyable
Yeah,
thing.
you feel refreshed, don't you? Okay. I think you'll know the answer to this. Okay. What is f doing from 4 to 7? It's increasing. Why? Okay, would everybody agree with that? Okay. So Megan, f prime is graphed above. Specifically, Hannah's going to do x equals 4. Okay, you're going to do x equals 2. Specifically, what is x equals 2? X equals 2 is a critical number for a what? Now, this is according to these three young ladies. Increasing, decreasing, increasing. Right? F is. I don't know what F looks like, but it's increasing and then decreasing. Correct? So it's a critical number because its derivative is 0, right? But it creates a certain kind of point. What kind? Which one? It's going from increasing to decreasing. You said from increasing to decreasing at 2. Right? Okay. Hannah, x equals 4. How is it special? A relative minimum since f changes from decreasing to increasing at 4. Okay? So let me understand this right. F starting somewhere, correct? Increases till x equals to 2, then turns around and decreases till it gets to x equals 4, and then increases. Does that sound right? Cullen, what is the integral from 0 to 2 of f prime of x dx? From 0 to 2 of f prime of x dx. 13 is correct, because it's asking you for the area under the curve, correct? Yours is the hardest. What is yours? Okay, well, let me give you a little hint. Okay, let me be fair. Okay? F is increasing till it gets to 2. Would you agree? It's increasing 13. It went up by 13. Just like 1 comma 5 and 3 comma 15 increased by 10. Right? And then it turns around and decreases. Yes! -8, because it's going, that's how far it's going in the opposite direction. How do we show oppositeness? Negative. Very good. Is it kind of making sense? So, Hillary, from 4 to 7 f prime of x dx. What are you going to say?
43.
43. Okay? Everybody got that? These are some of the hardest problems on the AP exam. I know you're going, really? Yeah. You know why? Because I did a poopy job teaching it. Now, what do these numbers represent? The amount that f increases, f, not f prime, correct? F increases or decreases. You also, Abby, have a hard problem. You're told f of 0 equals 3. That's the initial value, folks. That's the y-intercept, isn't it, of f. And I know it's increasing from 0 to 2, correct? I know how much it increased from 0 to 2. 13, correct? So, what's f of 2? F's increasing to 2. It increases by 13, so, and it starts at 3. No. More than 10. 16 is correct. Okay, Maureen, you even got a harder one. What's f of 4? So what happens at 2, 16? It turns around and decreases, and it decreases by 8. It's 8. Perfect. So what is f of 7? Kyle. No. Yeah, you can. I'll ask you the next question. Okay? Holland, what's f of 7? You know at 4, comma 8, it turned around and increased by 43. So what is it? 51. Okay? Okay, you're going to get this one. What's the absolute minimum? Yep. Three is the minimum. Is the absolute minimum. Okay? Now, I don't ask you why, but why? What would be your justification if I asked you to write it out? Where can only absolute minimums and maximums occur? What? Okay. This function is continuous and differentiable, correct? Okay. And it's on a what kind of interval? Closed interval. And absolute mins and maxes can only occur where? And where? You're right, at the endpoints, correct? And this endpoint is smaller than all the rest. Okay. What's the absolute maximum, Emma? Since f is continuous and differentiable, correct? Or continuous, it doesn't have to be differentiable. And a closed interval. All right, backside. Okay, there's some properties you need to know. So if a and b are the same number, such as I'm integrating from 1 to 1 of f of x dx, you're really asking, what's the area between 1 and 1? You won't have any area. Does that make sense? Because there's no space, right? So this is 0. Then, on a definite integral, this needs to be the smallest number, and this needs to be the largest number. If it's not, you interchange them and multiply by a negative. The reason why, if from this point to this point, let's say this is A and this is B. Going from A to B, it's increasing, correct? But going from B to A, it's decreasing, isn't it? That's why we multiply by a negative. Then this is saying that if you are integrating from 3 to 7 f dx. Since to integrate, it's got to be continuous. You can integrate from 3 to 4 of f of x dx and add to it from integrating from 4 to 7 f of x dx. You can break it up into two separate intervals. All these properties are very, very helpful. This one they're saying is if that you get something like this from 0 to pi 3 times the cosine of x dx, and this 3 confuses you, you can bring the 3 out and just work on that, multiply your answer by 3. This is saying if I had something like this, I could separate these as two different integrals. Find the area under each of those curves and add them together. Yes, ma'am.
On number 4, when you said you could pull the 3 up, wouldn't the definite integral still be from 0 to pi?
Yeah, I don't know. I was thinking, I don't know why 3 came out of, where that came from. Another mental lapse. 25th time this morning already. What, like this? See it right here? So this is saying if I have something like 3 to 1 of x squared dx, I'd write that as a negative 1 to 3 of x squared dx.